Hello everyone, welcome back to our Ironbug workshop tutorial. And in this video, we are going to continue the heating system with hydraulic distribution system. So if you remember in previous videos, we covered the heating system as a zone equipment, and we also in the second video we also covered heating system with air loop. And today we are going to cover the heating system that is built from water loops. If you remember from the very beginning how the heating system is consists of, the first demo we just showed you the unit heater, which is a built-in system. And the second demo, we showed you the heating system that uses the end loop and the diffuser to distribute the heat. And today we are going to build a boiler and use water as a media to distribute the heat through the radiator or radiant panels. Let's go back to the slide. So mainly there are two kind of systems in this case. So the first one is a baseboard radiator. So basically they are kind of a similar concept inside the energy modeling world. So if you see in the real world, it's often see this kind of like radiator underneath the window, or there's another form of that is baseboard. It's the same concept, pumping the hot water through this device to warm the space. And another form of that hydraulic distribution system is radiant floor or radiant panel. It can be like a floor, you embedded these kind of like small pipes inside underneath the floor or inside the wall. And in some cases, these pipes are built inside the ceiling. So the concept here is the very same. It's basically you are pumping some sort of the hot water through these pipes and warm the space. What's the advantage of the radiant system is in terms of the thermal comfort, it's much better than the forced air system. If you see this diagram here, you can see this ununiform comfort zone versus this uniform, evenly distributed air temperature. And the second one is according to the DOE's report, the highest energy saving potentials. And because it's using the water pipes, which is much smaller than the air ducts, so it is more space saving for the mechanical equipment. But also it has some disadvantages. When you are using the forced air to heat the space, it's much quicker. Once you turn on the system, it blows the hot air to the space. It warms up the space immediately. But if I use this kind of a water distribution system, it usually has a time delay, and it takes some time to warm up the space. So it is a slow response time here. And because it doesn't take care of the moisture within this loop, so it only works with the sensible load. It doesn't take care of the latent load. And so you need a ventilation system whenever it's required. Now let's look at how this system is built. So from this diagram, we can see this is basically a hot water loop. And first of all, we need a boiler to convert the source energy. For example, the natural gas here, or we can use the electricity to heat up the water, and then use a pump to pump the water from the boiler to the terminal device. It can be the radiant floor or radiator or baseboard. And of course, we need a controller to control the temperature of the hot water. Let's open the number 3 heating before example grasshopper file. So this is the file that I copied from the previous step, and I remove the system here, but the rest is the same as the previous demo. I'm going to keep them here. Now let's build our first hydraulic heating system here. Okay, and first of all, let's go to the Ironbug tab. And because we have the looms here, the same thing, we need to build the thermal zones first and connect the thermal zone to honeybee looms. And now let's go back to the slides, check the here. First of all, we need to build some terminals for this system. In this case, we are going to use the baseboard as a terminal that is placed inside the loom. The baseboard is underneath the zone equipment. So we can see there is a baseboard. There are several baseboard. We are going to use a baseboard that uses hot water. This guy, zone equipment, baseboard radiant, convective water. And in this case, we need a coil, which is a coil heating water baseboard radiant. You can find this coil underneath the same zone equipment. Coil heating water baseboard radiant. And let's connect to the coil. And here you can see it's this coil also has to be connected to the water loop. So because it needs to pump the water from the water loop. Now let's build another one, a water loop. So underneath the 01 loops, plan hot water loop. You can just use this one. And it's very similar to the air loop. It needs the supply side and demand side. So for the supply side, which is a boiler and the pump at the supply side. And boiler, we can find underneath the loop components. It is here, boiler hot water, or you can double click to type in boiler. And pump, we are going to use a variable speed. And boiler, because the plant loop, we need to add the plant branches for the boiler. And let's use merge, this guy, merge. And for the supply side. For the demand side, we also need plant branches and then connect this boiler, connect this coil to the demand side. So basically, we generate hot water from boiler and then from the supply side, and demand side is this baseboard coil. Now next, what we need is a controller for the boiler. So in this case, we're going to use a simple set point menu scheduled. And so we are going to place this one right next to after the boiler. So we are going to control the temperature. By default is temperature of the hot water. I'm going to use 80 Celsius. And for the boiler, let's check what we can do. So fuel type, capacity, efficiency. Well, let's check what's the default efficiency for this boiler here. The thermal efficiency 80. I guess by default is fine. And let's see, there is boiler flow mode. So we are going to change this one to, so we have three options for this input. One is a constant flow, another one is a living sapling modulated, and the third option is non-modulated. So we are going to use the second one, living sapling modulated. You can, I believe I can just right click and click help. No, right click here, click help. So the first one is a boiler flow mode. The default, okay, this is the valid option. So this is the option where we can do use right click copy. Okay. And maybe we can also change the water temperature up limit to match the water outlet up the temperature limit to match our input here. And there are few places where we need to match the temperature. One is the sizing controls for this Plantloop. We can go underneath the number 0 sizing and controller to grab the sizing plant for this plant, and object parameter. So exit design loop exit temperature. So let's set to the same 80 Celsius and delta T. So typically we use 11.1 for the Celsius, delta T, which is 20 delta T in Fahrenheit. Okay, and let's check the temperature inside this coil. So, okay, in this case, the rated average water temperature is 87 Celsius, which is close to 190. It's a bit too high. Let's use the same temperature. So maximum water flow rate is the average water temperature. Okay, then right click, remove unused. So we can label this guy supply water temperature in C. Temperature. Let's see what else. We can do a test run. Okay, this one goes inside the equipment, and I guess mismatching the numbers. Yeah, we have 8 zones and one only have one zone equipment. We can duplicate this coil by right click, enable the duplicate number, and get the total number of the zones, list length. We get 8. All right. Now we have 8 zone equipment and 8 looms. It works. And we have 8 branches, 1 hot water loop. Now let's go to the HVAC system. So for the air loops, no, for the Plantloop, so we have 1 Plantloop. but we don't need an air loop, so there is no air loop for all these zones. No air loop. All right. So this is a system what we are going to assign to these zones. And let's see. System. Oh, baseboard. All right. We are still using the same New York City's example file, weather file, and let's just only looking at the amid for the heating set point. For now, no, this guy not here. Okay, let's do a test run. All right, we got the total UI it is 78. And let's look at the ambient hour. So, okay, this is the first 8 charts for the ambient hour for each zone. So you can clearly see for this system, there are some few hours, not hours, I believe this is the highest value is 0.17. I believe it's 10 minutes of the hour. So it only happens during the morning time. You can see very cold season is the morning time. There are few days. It is happening because, as I said, this system has a slow response time. So once you turn on the system, it takes like roughly 10 or 20 minutes to heat up the space so that the space can meet the set point schedule. So you can see also inside, you can see the during the December winter time during the December as well. All right, because this makes sense. And let's look at